evil genius there, with 2 L's, it's a joke. Please feel free to Twitter me through the session. And also, please ask questions. This is a live session. So if you have questions as I go through the presentation and through the demos, I'll look and make sure and answer any questions that do come up. So October 24th, we announced the preview of our Azure Container Service, Azure AKS for Managed Kubernetes. And it's really about simplifying the deployment, management, and operations of Kubernetes in the Azure cloud. It really, specifically, we talk about the main solutions here. It's talking about container hosting with optimized solution for the Azure cloud. It's an Azure hosted control plane. So the control plane of Kubernetes, and manager, the etcd, it's all managed by Kubernetes itself and managed with Azure as a service. You only pay for the resource consumption, which is one of the things that we announced. We'll talk about what we mean by that. But in essence, what we're saying is anytime I add a node, that node is what I'm really paying for that's going to handle the workload. We handle automated upgrades, self-healing, and easy scaling, and we'll show you that during demos. And it's really about ease of management of the Kubernetes setup. And more importantly, it's the upstream supportable Kubernetes. So full overview, we'll talk about, first, it is a fully managed Kubernetes control plane. That means the masters, the etcd, there's no VMs to operate, no patching required. So in essence, all you have to worry about is just your nodes and your workloads. It's provisioned under about 5 minutes, and it's getting faster every day while we're still in preview. At GA, we'll have an SLA available, 99.95%. And we transparently scale the control plane based upon your cluster size. So as you add worker nodes, you'll see that we'll automatically manage the control plane process. Again, I mentioned earlier, we are using upstream Kubernetes. So that way you know that as new features come out and we test it in the AKS service, when you do managed upgrades, which we'll show you also in the demo, that it's a supportable and all the documentation around Kubernetes, it fits that process. And as we mentioned on October 24th when we announced it, there is no cost for the control plane, which means it's free of charge for the control process. All you pay for is the worker nodes that you add to the service. So if you start off with just one VM, let's say a D2, and you increase in size from there or you add more nodes, that's what you actually pay for. Or more importantly, if you decrease the nodes, you also pay less. Today in preview, some of the features, obviously, we'll show you some Kubernetes upgrades and how we can upgrade both our nodes and the control plane through the API. Self-healing control plane, so you don't have to worry about the process behind the scenes. etcd is SSD backed, automated, HA, and backup and restore is all taken care of for you by the service. And then we'll also show you how you can easily scale the cluster to the workloads that you need. And if you look at the diagram below, the only difference here is that the masters are kind of taken out of the picture and it's managed by the Microsoft Azure team, and then you have the agent VMs that are going to be sitting in your subscription. We'll show you how that looks like in the actual Azure portal in a minute. As I mentioned, you can deploy this through the portal. You can deploy this through the CLI or Cloud Shell, and also any ARM templates or ARM deployment or a REST-based API. Now, some of the commands to get started, we have added, if you make sure you update your Azure CLI to at least 2.0.20, we added the AKS command set. So if you look at first, obviously you want to create a resource group that you can put your AKS cluster in. And I'll show you the regions that AKS is live in. I'll show you some links at the end where you can go and get the information. But first you want to go ahead and create your resource group. Then you have the new AKS command. It's as simple as AKS create, the name of your cluster, the resource group you want to put the cluster in, the number of nodes you want, so C stands for agent count, and then the Kubernetes version that you want to deploy into. By default, if you don't put K, we'll default to 1.77 today. And then you have AKS get credentials. Now this is cool because what we're doing here is we're actually pulling down from the fabric the kubeconfig file and merging it to your existing kubeconfig file for kubectl to work on your local machine. Now, once you have the cluster up, there's a couple of cluster scale or cluster operation commands as well. So first, if you want to get to the Kubernetes dashboard, you can do AKS browse and the name of your cluster and the resource group. And basically what that gives you is a proxy, just like you do kubectl proxy, and it gives you a proxy to the dashboard so you can use locally and check out the kubectl dashboard. We also have the AKS scale command. Now the scale command, what it does is it takes that number after C, the new agent count, and it will increase the number of nodes in your worker set, agent pool we call it, by the number requested. And you'll see that the nodes get added, and then they get put into the master set. And then when you do kubectl get nodes, you can see all your worker nodes. You also have AZ AKS get versions. Now, why this is important is that you can see at any point in time the current version of your cluster, and both your agent pool, which are the nodes, and also the master set or the control plane. And then what it'll also give you is what are the upgradable versions that you have to go upgrade to. So we'll see that also in the demo in a little bit. And then we have AZ AKS upgrade. Now this is where things get really cool and talk about the easy way. Now I can go ahead and just upgrade my cluster to a new version without me really having to do all the heavy lifting that we normally have to do. It's one API command. So in this case, AZ AKS upgrade, the name of my cluster, the resource group that I'm in, and then what version I want to upgrade to that I would have gotten previously from the AZ AKS get versions. Now, this does follow kind of like a rolling upgrade process. So we try our best as possible, as long as your services are deployed correctly, that services shouldn't go down. We do warn you in case something wasn't created correctly on the cluster. But normally, what we'll do is we'll cordon and then drain off any of the nodes before we do the upgrade. So again, we'll see that happen in the process when we do the demo. So let's get to the demo. So in this demo, what I want to do is I really want to go through the process of start from finish, and then I have a finished cluster, and then we'll talk through example workload that I deployed to my cluster. All right. So here I'm at my command line. So in this command line, I have my Azure CLI already upgraded. So what I want to do is I want to go ahead and I want to create a new resource group. And I'm going to go ahead and create it in Central US. All right, so I'm naming my connect-azmks-1, and I'm connecting it into my Central US region. I should come back pretty quickly, and there's my resource group created. And now I can go ahead and start AZ AKS create. And then what I'm going to go ahead and do is I'm going to go ahead and give it a name that I want to use. So we'll do connect-azmks. And then my resource group name, which is up here. All right. And then I want to give it the count. So how many nodes do I want to deploy at first? So I want to keep my price low. I'm doing some development. I'm not going to deploy a whole cluster with lots of nodes. I just want one node to do some testing of my app. All right. So I'm going to go ahead and do C1. And then I want to also make sure that I'm on 1.77, because right now that's what we're using in another dev environment or our prod environment, and I want to make sure it follows the standards. So we'll do -K. We'll do 1.7.7. All right. So as you can see right now, you have the option of putting -- no wait, so that you don't have to wait for the actual resultant set to come back and have to wait for the cluster to build. Now the cluster takes about roughly about 2 to 5 minutes, depending upon where you're building it and operations that day. But we're trying to bring it down. I've roughly seen it somewhere take on average about 5 minutes to build out my cluster. And you'll see some other cluster operations as we go through. Now what's happening is in the background, and I'll show you my portal here. So if I refresh my resource group listing here, here's my new resource group that I created. So there's the connect AZMKS1. So if I look at my resource group that I created and that I called on the command on, what it did was it created a resource object, that container service resource object, and there it is, the name that I gave it. Now, by default, there's nothing else in there right now, and there won't be. I can go into that resource object and look at some specific information about the cluster that I built. Specifically, again, the region that I'm in. Also, I can see that it is 1.77 on my Kubernetes version. There's my API server address. So if I'm tying this into any DevOps tools like Jenkins or Visual Studio Team Services, there's my address to connect to my API server that I would send all my kubectl commands or my Kubernetes API commands to. And then my agent count and my agent VM size. Now in my AZ AKS create, I could have defined specifically what size VM I wanted. Again, just make sure that those VMs are available in the Azure region that you're building your AKS cluster in. But from here, I can see, okay, well, I have an AKS cluster. It's starting to build. See, it's creating. Now, what you'll notice is very quickly, if I go ahead and refresh my resource groups again, by now there should be another resource group created on behalf of that resource that we created for the container group. So here it is. It's called MC underscore. It always starts with MC. And when I look at this resource group, this is the actual resource group that has all of my objects in it that are being created for my worker nodes. So as you can see, it's already starting to populate with a VNet, a route table, a network security group, and more importantly, the VM that I selected for my agent pool. So now, by default, what's happening is all of this is up, it's running, it's registering, and now what we're doing is running processes in the back to make sure that this becomes an agent node to Kubernetes. So the control plane will register it, we'll make sure and deploy all of the necessary pods to it, kubedns, your heapster, and more importantly, your kubelet, so that all the work can be done. So relatively soon, we should see back here at the command prompt, I'll get a return back that says, hey, you've got your clusters available, and it's going to give me a JSON output of all my cluster information. Now, if I go back to the slides for a second here, we talked about the creation here. So remember, when we created, I specified the number of nodes that I wanted specifically, and then more importantly, once it's created, I'm going to have to get back credentials to be able to talk to my node. Now, by default, those credentials are using certificates that have been created during the process, and then it will go ahead and put the client data key and key process on my local machine, so my kubectl will have focus now to that new cluster that is being built. And I can show you that command here. Let me switch over to another shell. And I have a cluster already built, so we don't spend too much time waiting on the other one. And what you'll notice is I already have a cluster set up here, and you can see in my shell I have ev-az-mks. So this is the cluster I built prior to make sure it's available. But I could easily just do let me go ahead and increase that size so you guys can see it. So I can easily go ahead and do AKS get-credentials. And then basically what's happening is, like I said earlier, it's going to merge that to my kubeconfig file. By default, depending upon what operating system you're running on, but in Mac or Linux, it will go ahead and default to your root .kube/config directory, and then merge that to that listing. So you won't lose any of your other connections that you may have or your other contexts that you may have. So now you can switch between all of your clusters and even Minikube if you're using Minikube locally for deployment. So once I get my credentials, and you can see up top, I've already finished my cluster, and there's what I said earlier, right? I was able to get under 4 minutes and 48 seconds. The cluster was built. So average about 5 minutes for my cluster to be built up here. So now, so I can get focused to that new cluster, what I'm going to do is I'm going to go ahead and just do a AKS list. And this basically gives me my list of all my AKS clusters that I have under my subscription. So you see here, I have the one I pre-created, and then I have the one that I just newly created here with you guys. So I'm going to go ahead and connect. So I have a question. In your initial example of creating one node, would that cost the same as a single IaaS VM? In other words, are you being charged for the equivalent cost of an IaaS VM for each node in the cluster? That's correct, Bill. So basically what's happening is if I stood up one D2, I'm just paying for one D2. And then from there, I can increase my cost. Now, there's other technologies like ACI, and there's projects like ACI Connector to connect Kubernetes to ACI, where we do per second billing on the actual container. But this is just a managed Kubernetes cluster with the actual nodes that you can deploy. And then you would want to, obviously, in actual DevOps practice, you want to make sure that you're monitoring this either Prometheus or OMS, Azure OMS. And being able to take this information about what's the right size for your cluster as you go out and make sure your worker nodes are sized correctly for your workloads. But yes, it's the cost of the VM itself. So in this case, I'm only paying for one D2 V2. It doesn't matter if I go to 300 nodes, 400 nodes, we're not going to charge you for the management infrastructure afterwards. Great question. So let's go ahead and get my credentials. So AKS get-credentials. And I'm going to give it the name here of my cluster, the new cluster that I added. We'll paste that in, and the resource group that I put that in, it's here. All right. So you'll see it says merge your current context. So as you can see now, I have my shell automatically telling me what my kubectl current context is. It's switched from my already pre-created cluster to this new cluster that I had created with you guys here live. So now I can go ahead and start doing my kubectl commands. So the first thing I'll do is we'll see, okay, prove to me that I only see the agent nodes. So I'm just going to do a get nodes, and there it is. You only see one agent, AKS agent pool 0. It's in status of ready, and then we give you a role attribute so we know it's an agent. In this case, you're always going to see agent. Age, and then what current version it's at. At this point, it's all kubectl API. So I can do all my kubectl commands, all my Kubernetes, any Kubernetes API command directly to this cluster. So now I'm going to go ahead and put up another kubectl get pods. We'll do all namespaces. So you see all the pods that are actually running in kube system. I have nothing deployed yet, so there's nothing in default. And we automatically go to the default namespace, obviously. But as you can see, I have my heapster running. I have DNS. I have kube proxy. And then there's a couple other service redirect and tunnel that's built for the AKS management infrastructure. And then we have the Kubernetes dashboard that we can get to. So as I mentioned earlier, we have the command az AKS browse. So I want to go ahead and browse to this cluster. So we'll go ahead and copy that here. And what that'll do is it'll automatically create a tunnel for me, and it will automatically open up my default browser and bring me to my Kubernetes dashboard. So from here, if you're more comfortable in the Kubernetes dashboard, you can absolutely go in and do operations from here, as long as that tunnel is up. As long as you don't escape out of that tunnel, you should be able to access anything here within the Kubernetes dashboard. And it is the standard Kubernetes dashboard. We haven't done anything special to it. It's exactly the same as you would get in any deployment on the version that we're on. All right, let's go back to our cluster operations here. So we'll control C out of that, so we don't need that anymore. Now, I talked about some other cluster operations commands I showed you on the slide. So the first thing after browsing, what I want to do is I want to go ahead, maybe I want to scale this cluster up. So what I'll do is I'll do az AKS, and I have the scale command. And the scale command basically is exactly what it sounds like. I'm just now say how many nodes do I want instead of that just one. So again, same concept. I need to give it the name and the resource group. Those are minimum required parameters for this command. And then I want to use -c. I could use also -- agent count, which is same thing, just written out. I like shorthand. So -c, and then the number of nodes that I want in my cluster. So I'm going to go ahead and burst it up to 3. Now, it takes average, I've seen it go anywhere between 2-3 minutes to add my cluster nodes, which is actually pretty good. But what I want to show you is kind of behind the scene what's happening. And you can see it in the portal, as I showed you earlier. Just like we saw the portal, you saw build out. If I refresh that resource group, that MC resource group, you'll see in a minute where it's going to add new nodes, new disks, and then, again, go through the process of making sure that, and there we go. So the nodes were built out. And you saw that it wasn't asynchronous. It actually happened synchronously. So you have A1, agent pool 1 and 2 being built out at the same time for you. So that'll take a little while as the kubelet and all the stuff goes in and it gets registered back to the control plane. Let's go back here. And you'll notice that we talked about adding these nodes. I can still do operations on my cluster as I'm adding nodes. So I can go ahead and add these nodes, still do operations, look at my cluster, send stuff to my cluster. Obviously, you want to wait to have all of the nodes up so that all the workloads can be split across the nodes if you have replica sets set out. All right, so let's go ahead and I'll show you the next command here. So when we talked about the scale, the next command you'd probably want to do is get versions, right? So if you look down at the bottom half of my shell, if I do az AKS get -versions, and again, I give it the name of my cluster and the resource group that the cluster is in, what's going to happen is it's going to give me, by default, because I have my AZ set up this way to output into a JSON. I can also do -O for output and output it to a table for easy reading. So you see here, my agent pool's at 177. My agent pool available upgrades is 179, 181, 182. My resource group, my master is also at 1.77, or the control plane, and then what I can upgrade to. Now you can't choose, I want my agent pools to be upgraded to this and my master upgrade to this, but it's just one upgrade command. So when you say upgrade, we actually take care of upgrading both. So the command for the upgrade process, and we'll go through that really quickly. Now that takes a little bit of time. On average, we're roughly close to currently in preview status. We're right about 9 minutes, a little bit less actually. I had 8 minutes per node that you have in your cluster for the upgrade. And again, remember what's happening. We're actually taking nodes down, cordoning off, draining any workloads that are on that node, and then moving things as we go through. So it's very important that you understand what's actually happening behind the scenes, because that time doesn't seem trivial when you see all the work that's actually happening. Now, if you try to do this yourself, obviously there's probably some scripts and some other things that you would do to make sure it would work, but this is, again, easier to run with just one command and let it run. So we'll come back to the cluster upgrade once we go through the scaling process, the node scaling process. Now I can go back to, I'm going to swap over to my existing cluster, so we can start looking at cluster operations and now look at deploying a workload to an existing cluster. So we'll do, we'll use our context, and now I'm swapped over to my existing cluster. Let me minimize this guy here so that we can see what's happening, but we have more space up here. All right. So in my existing cluster, I want to go ahead and look at, again, operations and what I have deployed to it. Now, what you'll notice is when I do on this cluster, I've installed both Helm and Draft. So Helm is a product, obviously most people have heard of Helm. It's our package installer, or the package installer for Kubernetes. It makes installing prepackaged systems or entire application sets into Kubernetes very easily, and it makes it repeatable, and you can just use Helm install and then the name of the chart. We'll talk about what that is, and I'll show you building out a Helm chart from using a draft, starting from draft from just code. But as you can see here, I have both Draft and Tiller. So Tiller is the server-side component of Helm that's running in my cluster, and then Draft D is the server-side component of Draft that I have running, also with this client side that's running on my laptop right now. So from there, what I want to make sure is, okay, I've got, in default, I do have an ingress controller. So as you can see, you can deploy an ingress controller into AKS. In this case, I'm running Nginx, and I deployed it with Helm. So if I do a Helm list here, I can see that I just installed the stable version of Nginx ingress controller, and it took care of deploying that for me. Now, what actually happens behind the scenes when I deploy an Nginx or any service that has the load balancer type under the service manifest. So if I go to the service descriptor for any service that I'm deploying in AKS or an ACS, and I deploy that service will automatically call the Azure API to build an Azure load balancer with a public IP address necessary to expose your service externally from the cloud resource. And we could see that from the portal. So if I go to my portal and I go to my existing cluster set, you'll see here I have this Kubernetes load balancer created. And that was created the minute I deployed my Nginx service. And that service will automatically create the load balancing rules that you define. So in this case, it's going to do 80 and 443 by default. And then it gives me a public IP address that it ties to. And then I can take that public IP and I can go ahead and tie it to Azure DNS for my DNS name or any DNS service, so that my services will point to this public IP address, which is the ingress point for my Kubernetes or AKS cluster. So we'll go back to the resource group here, and let's go back to my terminal. All right, so now what I want to do is, you can see here, we up top, it took about 3 minutes to add this the two additional nodes to the top cluster, and I want to go ahead and do AZ AKS upgrade. Good if I spell upgrade. And in this case, I want to go to 1.8. We'll do the 1.8.2. Okay. So again, this will be a long running. We're going to go move over into moving some code into AKS with Visual Studio Code using Draft and Helm, and then towards the end we'll come back and we'll show you how long it took, and then my terminal will actually tell you how long that command took to run. So I'm going to go ahead and run that. Again, it does warn you, Kubernetes may be unavailable during cluster upgrades. Are you sure you want to perform this operation? Yes or no? Now, this is really talking about any services that you deployed. Again, verifying that those were built out correctly with proper replicas. In case of ingress controllers, your ingress controllers are also in HA fashion to make sure that nothing actually goes down your services. But in most cases, if everything's built out correctly, the proper HA processes will take over, and with just short timeouts or time to live outs for DNS or anything like that, you may see a little bit of an outage blip, but not much. So I'm going to go ahead and say yes, because I have nothing deployed to this cluster yet, and let that operation run. It is a long-running operation, again, depending upon how many nodes you have in your cluster. But again, this is in preview, so it'll happen faster and faster as we perfect the processes in the back end. All right, so let's go back to, again, we'll minimize this, and we'll go to my working cluster. So I have really nothing deployed to this cluster yet. So now we're going to go to Visual Studio Code, and I have a small little API app that I wrote. Nothing spectacular, nothing major. It's just a small API that writes to Cosmos DB running Mongo. So basically the Mongo API for Cosmos DB. And I'm going to use that as my document store for my API service. That's basically a lookup for global black belts. So I can do basically CRUD operations on this data store and add or delete or update any new records. So as you can see, I have a very simple, it's a server.js file with Express, MongoDB client, a parser, and then a config that I wrote. And then in that config, it's basically connecting to my database. Now you'll notice my database is using the environment variable connection string, because I want to pass into this container or to this pod my environment variable for the connection string. And I'm going to use a Kubernetes secret to do that. So that way I'm not exposing any secrets for my databases directly into my code. And it makes my code very portable into any environment. And then I have some routes, and this is where my code is, actual code is. And I just have my basic CRUD operations, get, delete, post, and put. So I also have a Docker file. So most likely local development. I'm working on Docker locally, making sure that I can put it in a container and it works as is. And I'll do a Docker build local on my laptop. Again, the beauty of containers and making sure that it runs on my It runs in my laptop. It'll run anywhere else the same. So I want to do local development. I write a Docker file. The next thing I do is actually use my draft. So we'll just do Control-K here. So Draft is another application from the Deis team that's now part of Microsoft. And Draft allows, it's kind of like a short circuit for developers to take code directly and build out a Helm chart for you, and then actually deploy it to Kubernetes, let's say a sandbox environment or a dev environment, and then be able to go ahead and start real testing live while you're editing code as well. So I can edit code, do a draft up again. We'll talk about draft up, draft create, to make sure that any changes that I make to my code are representative in my sandbox environment, and I can see what's happening in real time. And the beauty of that is, because it's tied to also my image repository, I can tie draft to my image repository when I initialize it. It also creates the container and pushes the container to my image repository. So if you have any DevOps processes that pick up on when a new image, a webhook, on when a new image is deployed to, let's say, Azure Container Registry, it'll pick up that new image is deployed, and then you can go ahead and make processes or make pipelines built upon that process. So for the first thing I'm going to do, as you notice, I don't have a package.json file. I haven't done npm install any of my modules yet. So it's just a normal JSON script or a JavaScript file, a Node.js file that I created. So the first thing I'm going to do is I'm going to go ahead and do a draft create. Now what draft create is going to do is it's actually going to it's going to kind of deep scan my file system here and the folder that I'm working on. And let's just verify I'm on the correct folder before I do that here. So I'm in the correct folder, repos, gbb API-pre. And I want to go ahead and you can see I'm running node 8.60 here. I want to make sure that I'm in the correct folder, and I'm going to do a draft create. And you'll see that it went through and it said, oh, I detected with about 93% certainty that this is a JavaScript file, and it says ready to sail. Now, what actually happened, if you looked on the left-hand side, it actually updated a couple of files, and it added some files here. So one of the files it added was the draft toml. The draft file basically gives it the detail of, hey, this is what I want to run when I do draft. As you can see here, it creates a random name for my service. So if I actually deploy this, it's actually going to show with that service name appended to the front. So measly skunk. So again, uses that kind of randomized name process. I want to actually go ahead and give it a real name before I deploy it. So I'm going to put a name in there. I can also change the namespace that it will deploy to when I deploy it to Kubernetes, or when draft deploys it to Kubernetes in my draft up. So I'll leave it default for now because I don't have any other namespaces to my cluster, but I could technically change that if I wanted to. The wait, watch, and watch delay. Now, watch is kind of cool. Watch would actually sit there and it would actually wait for file system changes and then do a rebuild and a repush. So basically, kind of like an auto draft up. We'll show you that in a minute. But in some cases, you don't want to do that because you want to make bulk changes then before you update it. So we'll leave it at false for now, and then I'll show you how we can just keep doing draft up and get our code back up. So besides that draft toml file, it also created a chart directory. And that chart directory has in it the code base that it determines, so in this case, JavaScript. By the way, you can override which pack it uses by default by using the -p parameter on draft create. And you can force it to use a specific pack, and draft comes with a few packs built in. Go to draft.sh to find out more about how to build draft packs, and all the plugins are available, and some of the processes. So you can see here it created a charts, which is an empty directory right now, and then a templates directory, and this is where I want to focus on. So in the JavaScript directory, it has two main files: the chart.yaml file, which when I look at that YAML file, it basically just gives me some details that this is an API version 1 for draft. It's a Helm chart for Kubernetes. It's under JavaScript, and then just a version number. The value files is really important. The value files is basically variables that I can plug into my Kubernetes YAML deployment, service, secret, I'll show you that in a minute, or ingress files that I can then draft will send to Kubernetes API to deploy my service for me. So I'll show you that in a minute. But you can edit these value files, and it reads it and feeds it to the Helm chart when the Helm chart deploys. So when we talk about a Helm chart, what are we talking about? When we look at the templates themselves, we actually have these templates that are built out to deploy a deployment, an ingress, and a service based upon the pack that I built. So as you can see here, it's using the Go templating language to be able to take some of the variables from the system, and again, under draft.sh docs, you'll see some of the variables that are built into the system. And also, it's looking at that values file that's being passed into Helm or draft when you upload it. And it's actually looking for specific areas within the value file. So in this case, where it says image, it's looking at the values file, and it's looking at the section called image, and then a section called repository. So again, if I go back to my values file here, if there was an image here, so image, repository is node, tag is on build, pull policy if not present. So if I go to my deployment, those things would be pulled in here from that value file. So now that I have my draft up done, draft create, and I've got my template out, I would go ahead and start editing these files to customize my build if I want to. I can go ahead and add more values to my value file, put in things like secrets, and so on and so forth. So I already have one that's already completed. So we'll show you that. Let me go to my other code. So in this code base, I've already edited some of my template files. So one of the things I've done is I've added a secret YAML to my templates directory. And here, basically what I want to do is I want to add my MongoDB connection string as a Kubernetes secret, and I want to push that with my deployment. And one of the things that's important is I want to make sure that that secret is in the Kubernetes prior to my deployment and my service being deployed. So what I've done here is I have an annotation that I actually have pre-installed. There's pre-install and there's post-install. And with this annotation, and when Draft calls Helm to push this package, it'll go ahead and make sure that the secret is created first. And then when that's done, then my other deployment and my service will be deployed into the API, into Kubernetes. So that, again, I just used some of the value files here for my values secret key and my values secret value. And then in my values file, which you want to make sure that that's on your git ignore if you're putting this in Git. But it's just the base 64 encoded connection string for my Cosmos DB connection. So I have my values file updated with things that I need. I changed it from cluster IP to load balancer, so I get an Azure endpoint that I can hit. And I changed the external port to 8080, and that's about it. The only thing I added was my connection string. And then under my templates, all I added was my secret YAML. And my deployment file, I went ahead and you'll see that I added an environment variable for my secret. So I'm referencing my secret that I created. And again, it's just using variables from that value file. And I also added another environment variable for queued pod name. So I can make sure that when we're load balanced, that I'm actually load balancing across multiple pods. And I can actually see the pod that made the request or answered the request. OK, so I have my code. It's ready to go. I have my draft file now. So now how do I get it up into my code base? So I can easily now go to my terminal here. And let's go make sure we're in our repo. So we're in our repo here. And let's just double check. We got all of our files there. Perfect. So now I can do a draft up. So draft up is what signals the command say, hey, take this, look at my charts file, make sure that you're in that directory. It's going to look at that chart directory and say, okay, I want to go ahead and start building this package based on the Docker file that's in my directory. I'm going to go ahead and upload it to my registry that draft was tied to on initialization. In this case, I tied it to my Azure container registry. Now, it automatically creates a secret for you as well in Kubernetes for draft so that it can do the proper image pulls. And then it'll go ahead and deploy that pod. Now, remember, it's deploying my secret first, and then it will deploy my workload, my deployment, and my service to the cluster. Now, this takes a little time to build. I didn't do an exact super efficient Docker file, but you should see it takes about a minute and a half for my Docker file to build, about 35 seconds for my Docker for it to upload to my Azure container registry. Actually, it built pretty fast, which is pretty good. There we go. So I've got my Docker image built. I've got my Docker image pushed to my container registry, and now it's releasing the application to my kubectl, whatever context I'm in right now. So I was pushing to, as you can see, the cluster EV AZM right? So from here, I should be able to kubectl get pods. Remember, I deployed it to my default namespace, so I don't have to look at any other namespaces. And there's my API. I have two replicas going, and there's my API pods, and they're up and running. So it was pushed out. And I can also do my kubectl get secret. Oh, did not do the command correctly. And you can see it created my Cosmos DB secret here, and it put in the proper connection string so my pods can come up. So now I want to test that. So there's a couple of ways you can do that. Because I created a service with an endpoint, with a load balancer endpoint, I'm actually able to go ahead and hit that through the Azure load balancer. So I can go back to my portal here. Well, I can do one of two things. I can go to my portal, look what my public IP address is, but we write back to the Kube API the IP address of the actual public IP that the Azure load balancer received. So I'm going to do kubectl get service. And that was pretty quick. We actually got it. There it is. So my GBB API JavaScript went ahead and got a public IP address, 52.168.10.109. So I can test that here directly with that public IP. I could also do draft connect. So if you don't expose your service as a public load balancer, let's say you expose it as cluster IP and you only have local IPs just for testing or dev, You can do draft connect. And what we'll do is it'll proxy to your app. So you'll see here in a minute, this is my log, my console, my logging of my actual app. So it says we're live on port 8000. It's a little misleading here because of the way I wrote the code. But you'll notice here it says, hey, I have your app connected on localhost 51.513. So I can take that and I can put that in. We'll use Postman to do some gets. So I'm going to go ahead and paste that in here. And I know I have a health. I always add a health path to my services and make sure it responds back okay, so I can do my liveness probes and my readiness probes for my pods. So in this case, I'm just going to go ahead and make sure my health is coming back with an okay. And there's my okay. So I've got my services up. It's responding with okay, both on the local host. And now, if I click in and I go to my actual service on my public load balancer endpoint, let's go get that IP address again. Oh, go back here. So there's that public IP. Just to make sure, just to show you there's no smoke and mirrors, it's the same thing. So I can go to my public IP, and again, I'm pretty sure that's port 8000, and I'm going to go ahead and do health. Oops. And we'll do a send. Got back okay. So I got both my public service and my locally proxied service responding back okay. And I'm gonna go ahead and close out the local proxied one. I'm just gonna go ahead against the one that's in the load balancer. Because what I show you is it's actually gonna show me what pod it's responding with down here at the bottom. So the next thing I wanna do is I wanna make sure that my actual API is listening. So what I wanna do here is, let's go. The directory I have for my API to respond is GBB Finder, right? So with if I just do a get to GBB Finder, it should come back with the current list of all of the entries in my Mongo database. So you can see here I have entries already listed for some of my my peers on the GBB team, and I have their skills, their name, and where they are physically located. Now you'll notice I have one null entry here. So I have my ID here, so I'm going to go ahead and I want to do a delete operation on this specific entry. Before I do that, I'm going to show you that I'm actually writing to Cosmos DB in Mongo. So when I go to my Cosmos DB in my Azure portal, let's just go to. So here's my Cosmos DB instance that I'm writing to. And I can go ahead and do my Data Explorer, which is kind of cool. I can see my collections here, and I can actually see my documents by ID that are directly right in the portal. So in this example here, you can see I have a couple of different, all of my peers, all the entries are exactly the same. And there's that null entry, right? So it's FC563. So what I want to do is I want to go back to my Postman here, right? And what I want to do is now I want to do a delete operation, and I'm going to pass it that ID, right? So I want to go ahead and do a delete. So I want to make sure that my CRUD is operating correctly, and boom. So the GBB with that ID number has been deleted. So now if I go back here, and let's go and let's do a refresh on my documents. Let's do a refresh here. And there's that ID is gone now. So you can see that I'm actually writing to my MongoDB in Azure from a container in a pod that's running in AKS. And I can go ahead and do update operations on my API from here all day. So now let's go back to our application here. Oops. All right. We can control out of that because we no longer need the local port because we have the clustered load balancer port here up and running. Now, from here, again, all of my operations are the same. So if I do, if I go ahead and do a kubectl get service, as I said earlier, my service is listed. I can do describe service, but more importantly, when I want to delete my service, I could use my my kubectl and list all my services and my deployments and delete them if I need to. But because I did everything in draft, I'm going to kind of stay in that loop within draft. So within draft, I'm just going to say, oh, I'm sorry. Because Draft used Helm, I can use Helm to list my deployments, all right? So I'm going to say Helm list. And earlier we just saw two. We saw Draft was deployed with Helm, and we saw that, that Cold Possum release, which was actually my Nginx. Now I have my GBB API listed in Helm. So I can use them all my Helm operations because, again, Draft kind of creates that template for you, but then Draft Up kind of uses Helm to deploy the code to the actual Kubernetes server. So now within Helm, I can do all the things that Helm does. I can say, hey, I want to go in and add code, and I want to delete it. But more importantly, since I'm in Draft, I can go and edit my code any which way I want. So I can go back into Visual Studio Code here, and I can add things to, let's say, let's go to, where is it? Let's go to routes. Oop. All right. So let's say I wanted to add another operation to this program. So I wanted to make sure that I had, maybe my put didn't work correctly to update. So I went ahead and added my put command here, or my put operations, into my code. When I hit save, I can go ahead and do another draft up directly within my terminal. So from here, I would just have to do, once I saved my code and then did draft up again, it's going to go ahead and take care of making sure that my code, the updated code, so it's going to do a new build, it's going to do a new release, and then it's going to go ahead and send that up to my Kube server, my AKS server. So you'll see much faster this time because it's just doing the delta changes. And you see it took a couple of seconds here on each one, but now I have my updated version of my application deployed. Now it didn't change the service, it didn't change the secret, nothing changed, so it was very quick and seamless. So technically I can just bring up my Postman again, and now I can go ahead and do a put operation to update a specific entry if I wanted to. So let's go ahead and do a get again, and I'm going to pull up one of my peers here. So we'll do Joey. So I get his ID here. And then what we'll do here is we'll do another operation with his ID. But this time I want to do a put. So I want to update something. And I'm going to go ahead and update the body. So let's just say I want to update, well, we'll update his skills. And let's see, I'll do, we'll just do draft and Helm. So hopefully Joey's watching this, and now he's really good at draft and Helm, and I've updated his skill set. But from here, once I go ahead and hit send, why is it doing that? Go back to this one here. Oh, my send button disappeared here, but let's see. There you go. We'll send that. So I have an error here on my put. So I have a, let's see, where did it do? GBB Finder. And I'm pretty sure it's because I have to have the rest of my values. Let's do a post. We're going to add a new person here. Make sure my post is working correctly. So we'll do skills. We'll do name, and we'll go ahead and add a new person. Call him Dave. Oop. And we'll add a new location. And we'll say he's in Redmond. Cool. And then we'll go ahead and submit that post. There we go. So now we have a new ID, a new person. I've updated the MongoDB database. And so if I go back to my portal and refresh, I should have my Dave living in Redmond with draft and Helm skills and a new ID, so a new person. So all my commands are working correctly with my updated code. If I go back to, let me close out that dashboard here. If I go back to my code base, right, you can go back here. Just make sure this is running. Now you can see where the upgrade, it's still going on. The upgrade process is still happening. And what's basically happening here is, again, we're adding the new node, we're taking nodes down and we're adding nodes with that upgrade process to that cluster that we first built. So we'll come back to that in a second. Again, don't forget to ask questions during the process if you have any questions on what's happening behind the scenes. Now, if I wanted to go ahead and delete this cluster node, or I'm sorry, this process, this service, very simple, Helm, and then I want to go ahead and delete that deployment. So again, I want to make sure list, I want to get the name properly, that release. And there's my GBB API release. So I can do a Helm delete, and then do GBB API. Now, purge actually removes all of the cache data about that release. If you don't do purge on the next build, it could be a little bit faster because there's cache data. But I can go ahead and just purge this out, and it will go ahead and remove this deployment and everything around it. So if I go ahead and do purge. Now, what it won't delete is my secret, only because I didn't add another annotation to my secret in terms of how I want that secret to act when that deployment is deleted or using Helm. So you can make sure and tie it so that you can delete all resources upon creation and upon deletion. So there you go. Release GBB API is deleted. So now my service is gone. If I do my kubectl get service, service is no longer there. And if I do my kubectl get pods, I'm just back to my ingress controller. And now I want to go ahead and let's say I'm done working with my AKS cluster. I don't really need it anymore. I can delete my cluster if I wanted to. I can just scale it down to just back to one node if I need to, so to make sure that I'm on the lowest cost possible. But if I wanted to delete an AKS cluster, it's AZ AKS delete, and then again the name of the cluster and the name of the resource group it's in. Let me just pull that up real quick by using an AKS list. Can you run Kubernetes on your own VNet? We're going to talk about that in a second. I'm going to pull up a slide here on features and closeout, and then we'll talk about some of the options that are going to be available, hopefully at GA and in the future. So now that I have my cluster built, listed here, I want to go ahead and delete it. So we'll do AZ AKS delete -n, and then here's my name of my cluster that I was working on, and my group here. Right. And am I sure I want to delete it? Now, this is also, it's not a long running operation, but because the command line is waiting, you should add a --no--wait to the end of your command so that you can move on to other operations. If you hit yes, it's going to wait, and the command prompt is going to kind of sit there and wait until you're actually finished. So if I'm going to go ahead and hit no here because I need that cluster for later. You'll notice that up top, as I said, it took about 27 minutes to upgrade a 3-node cluster to version 1.8.2. So I was kind of right on the money there, roughly between 8 to 10 minutes per node on the cluster for an upgrade. So you see there exactly the long-running operation, or the operation itself from that upgrade command. So let's go back to the deck here, and let's finish up with some features. And then we'll... So today, AKS will deploy its own VNet, and it is a pretty large VNet. It's a 10.0.0/8 network. We are hoping at GA that we're going to have custom VNet capabilities. So in that case, you can deploy your agents into the VNet within your Azure subscription. So you don't have to worry about that. So that's one of the major things that we're going to be deploying at GA. A couple of other things that we're going towards, and hopefully either at GA or not too far after GA, we're trying to add RBAC with AAD integration. So in that case, when you do kubectl, we're actually using OIDC auth so that you can actually authenticate against your Azure Active Directory. If you have two-factor auth tied to your Azure Active Directory, it would two-factor auth you, and then it would go ahead and bring you into your kubectl context. And more importantly, because it's tied to RBAC, whatever roles your user account was assigned to in Kubernetes. We're also looking at virtual node pools. So by default, we only deploy one node pool. And what we're trying to do is make it so that you can create different node pools for different workloads. So you can have an agent pool with smaller VMs, larger VMs, and more importantly, hopefully sometime in the future, maybe GPUs or FPGA type VMs if that ever comes out. The GPUs for real big data type workloads, that would be amazing to be able to do some of those NVIDIA GPU series VMs. And then agent pool management, so self-healing on the agent pool itself, so actually like a monitor that's looking at the agent pool, and if a node is having an issue and we can't talk to it over a certain period of time, we'll go ahead and kind of rip it out and bring a new one in and let Kubernetes do the operation of managing your workload. And then auto scaling is obviously one of those things. Not just auto scale within Kubernetes, because we have that already, but auto scaling of the underlying infrastructure. You could use OMS and potentially use some triggers from OMS to automate the scaling based on the AKS scale command if you wanted to today, but we want to kind of build that into the process to see based on workload. And then the Nirvana would be a hybrid cluster with both Linux and Windows workloads. So now you can deploy Windows containers to your Windows servers and Linux containers to the Linux servers just by using either node labels based on the node type, which are available today. So with that, kind of want to reference some of the call to action and some of the locations you want to get some of our documentation. AKS documentation is under our docs.microsoft.com/Azure/AKS. Great resource. It also has a walkthrough to get you tested, and it lets you also use the Cloud Shell within Azure to do all of these commands as well. Go ahead and start deploying some AKS clusters now. East US, West Europe, also Central US just came online yesterday. So you can deploy, as you saw, I was deploying to Central US. More regions will come on during the preview process as we build out capacity. And what you can also do is you can check our GitHub repo for github.com/Azure/AKS. We're not tracking it for code. It's more for any issues or announcements that come up during the preview process. And be an active previewer. So as you're seeing things and you're testing the cluster, really test it out, because when we go GA, we want to make sure that this is the best class service. And the only way we can do that from an open community is from your feedback and making sure that you give us the information that's coming out of your test and trials. So test it out. Put some workloads in it. Try some really crazy workloads and make sure that we can get a good footprint of capabilities and concerns from all of our customer base and our deployment base. And always revisit Channel 9. AKS, Scott Hanselman had a great presentation yesterday of a preview for Visual Studio and Visual Studio Code connecting to AKS automatically for true end-to-end DevOps experience, which is really cool. And you'll see more stuff as we come through preview into general availability, some of the amazing tie-ins to our Azure Container Service. That's it. Thank you very much for attending my session. And if you have any questions, again, make sure and post them. Send them to the AKS team on our GitHub repo, or you can Twitter me at evil_genius. Thanks.